here. So what is happening is parametric equations are just separate x and y outputs. Like this is an actual output you'll see right here. And that is an actual output, which is the second equation. And what is happening, here's this little example, guys. A golfer is just hitting a ball, and this is just representing horizontal distance per second. And this is your plain little quadratic like you did in Algebra 2. This is going to represent like the height of the ball. It makes a little U shape. It goes up, then it comes back down because of gravity. And then what we're going to do is we're actually going to combine this stuff. And on this chart right here, we're going to see horizontal distance and vertical distance on the same graph. That's all a parametric equation is. And then if you remember, in part 2, I think I put the page away, but part 2 of today's lesson, we're going to take these two equations and write them as one single equation to show this stuff at the same time. So here's what we're going to do. We are going to make a table of values to represent the path of the curve just for these seconds. And this is pretty important. There is always a restricted domain. And I will give that to you. That will be part of the problem just like it is here. So here's my t column for this value right here. I'm just going to write 0, 1, 2, 3, 4, 5. And I just got that from here. And all we're going to do is we are just going to take these values and plug them into both of these, and these are going to be our x and y coordinates. So this is our input, but these two are actually both dependent on this time. So when we plug in 0 for this top equation, guys, that's going to be 0. 1 times 92 is 92. Plug in 2 right here for the t value. 92 times 2 is 184. 92 times 3 is 272. 92 times 4 is 368. And 92 times 5 is 460. So what that means is after 5 seconds, that golf ball has a horizontal distance, like as the crow flies, of 460 feet away from the golfer. All right, so now let's take these same values and plug them in down here. So of course, since they both have a t value, when you plug in 0, it's 0. When we plug in 1, we are going to get an output of just 76 because that's a negative value right there. Now, when we plug in 2 to this bottom equation, we get an output of 120. After 3 seconds, that ball, or that golf ball is going to be 132 feet. At 4 seconds, it's going to be 112 feet. So obviously in between these two, it starts falling again. And then after 5 seconds, the ball is at 60 feet above the ground. So remember, this is above the ground. This is the distance from the golfer. So let's go ahead and plot these ordered pairs. So, of course, everything was starting at 0, 0, 0. So we're going to have that right here. And then these are going to become our ordered pairs. So 92, we'll put this along the x-axis. This is horizontal distance. And then our y-axis is going to be the height that the ball reaches. So we'll just kind of estimate. So we'll say this is 100, 200, 300, 400, 500. And I'm just going by this value right here since this is the highest value. I just kind of broke off my increments to fit all of my data. All right, let's take a look at the scale. This is from 0 to 130. So I think that I will just kind of make them in increments of 50. So we'll make this 50. We'll make this 100, and we'll make this 150. And everything is going to fit on our graph. Okay, so 92 and 76. 92 is like right here. 76 looks to be about right there. And then 184, 120. 184, 120. 272, 132. 272, 132. And guys, we're just kind of estimating. There's no grid lines on here, so we're just kind of, you know, sketching where the ordered pairs might be. 368 is like right here, and then 112 is going to be climbing back down again. That looks like a good spot for where 112 would be. And then 460 and 60 is about right there. Okay, so we have made a table. There's our table to represent the curve. We've plotted the points onto the graph, and we are going to connect the dots because it is continuous. But remember, we have a restricted domain with brackets, so we have our closed dots to show the brackets, and then just kind of trace that along the best that you can. And that is going to represent the graph. So notice we have a blank space right here because we have a restricted domain. And that's all a parametric equation is, guys. Let's go ahead and take a look at the next page. So for these values right here, before I keep going, I wanted to give you a little bonus point if you have some bonus points if you have your volume on. So if you have your volume on, if you turn in your notes and tell me that the code word is Red Bull, because that's what I'm drinking. If you tell me that the code word is Red Bull, you get 10 extra points on today's assignment. Thank you for having your volume on and being patient with me while I talk through this. All right, number 2, guys. For each pair of parametric equations, we're going to make a table of values. So this is going to be part A. Then we're going to draw the graph and show the orientation, and I'll talk about that. That's not really any big deal. That's going to be part B. And then part C is going to be a rectangular equation. And you've actually done this before. We just haven't been calling them rectangular equations. So when we get to this, it will kind of look familiar to you. All right, back to part A. Again, we have a restricted domain. So I'm going to put T here, X here, and Y there. And that's 0 through 4. All right, so again, we plug these numbers in twice, once for the X equation and then the second time for the Y equation. When you plug in 0, you're just going to have a constant of 1 here. When we plug in 1, we're going to have an output of -1. When we plug in 2 here, that's going to be 1 minus 4, so that's going to be a -3. That is going to be 1 minus 6. And then this one is going to be 1 minus 8. All right, let's plug these in over here. These are all positive numbers, so this is just going to be a 2 and then a 4. These are just even, 6, 8, and then when I plug in a 4 times 2 is 8, plus 2 more is 10. Okay, so now let's go ahead and plot this, but let's pay attention to how the plots are being formed and in which direction it's going. So when I plot +1, +2, it's going to be right here. -1, +4. And then we're going to have -3, +6. And then -5, +8. So there's -3, -4, -5, +8. And then -7. So there's -5, -6, -7, all the way up at the top. Okay, so as we went down our list in order, this graph, it looks like a linear graph, and it made that direction. It went off towards the left of our paper. So let's go ahead and connect the dots. And that's what I get for not using my straight edge. And guys, the orientation, remember the graph was climbing this way. So all we're going to do is just draw some arrows along this graph just to show the direction as we progressed down that chart. That's what the orientation is. It shows those arrows. Okay, now for a part C, you have done this before. It's called a composite function. All we're going to do is take the first equation, which is x equals 1 minus 2t, and then solve for t. All right, so we're going to solve for t here. So I'm going to move the 1 over. I'm going to divide both sides by a -2. When I move the 1 over, it's negative. And remember, we are going to divide both sides by -2. So t is going to equal x minus 1 divided by a -2. So that negative just hops out in front right there. And then once you get t all by itself, we're going to substitute this in for this value over here, and that's going to turn into a plain equation with the letters x and the letters y. So take an equation, solve for t. Once you solve for t, plug it into the other equation. All right, so here we go. We are now going to have y equals 2 plus 2 times this, because this is what t equals. So it's a fraction. All right, and then guys, go ahead and clean up and do your order of operations. Remember, this is a fraction. That's one term. We're going to distribute the 2 once. Those are going to cancel out. So this is going to be y equals 2. Remember, a positive times a negative is a negative. So 2 minus x. And then remember, this is minus that 1. So that's going to turn into a plus 1. So this is going to be y equals -x plus 3. And that, oh, I shouldn't turn it sideways. That is your rectangular equation. 2 steps there. Solve for t, step number 1. Plug into the other equation, that's step number 2.